Welcome to Explorer Classroom. My name is Gibbs Kuguru. I am a shark scientist and a National Geographic explorer, and I will be your host for today. At National Geographic, we believe that anyone can be an explorer and that you have the power to make a difference in the world no matter how old you are. Explorer Classroom is here to inspire you with stories from the field and connect you with our National Geographic explorers live to answer your questions. Before we get into today's lesson, I'd like to welcome all of the following classes who are joining us today, especially the Day Family Homeschool, March Academy, Knock Primary, Fulton School, Barker Middle School, the Adams Family Homeschool, Dr. J. Michael McGrath Elementary School, the Lakin Park School, Headway School, and Wurtland Middle School. We are so glad you are here with us today. Today, our explorer is Zoleka Filander. Zoleka is a marine biologist and a deep-sea researcher whose work focuses on the taxonomy or identification and classification of organisms. She's originally from the rural outskirts of South Africa and is currently based in Cape Town on the western coast. Her research takes her into the waters off the coast of South Africa, where she documents the various coral species found there and even reports on new species. She's an active science communicator working to transform marine science in South Africa and has started a mentor program to create opportunities for the next generation. We are so excited to have Zoleka here today. She's going to tell us all about deep sea coral, the detective work of taxonomy, and why it's important. Zoleka, welcome to Explorer Classroom.
Hello, everyone. It is such an honor to be here with you today. It's quite late in the evening this side. We have no electricity, but you know what? Being an explorer means that you need to compromise, and here we are, being able to connect. So I'm really thrilled to be here, and I hope that this classroom event is going to be as informative as I have anticipated.
Yeah, and despite the challenges, thank you so much for joining us today. Could you tell us a little bit more about the work you do and why it's important?
So yeah, as you've already mentioned, Gibbs, I am an explorer that sort of tries to better understand the deeper parts and the animals that live in the deeper parts of the oceans that surround South Africa. And today I'm going to specifically be sharing a part of my work that really focuses on identifying, classifying, and just telling species apart. And the most amazing thing about what comes across as a basic skill is that it has helped me be able to expand my interests and not just look at one specific animal, but look at how different animals interact as a community in a particular area, why their homes might be important, what's so special about them, with an idea to really protect, preserve, and better understand how these bits and bobs of the ocean come together and give us all these services that we get from it. So yeah, that's me in a nutshell. But enough about me. Just to give you an idea around how the classroom event is going to go, we're going to start off by watching a very short animated clip, which is really going to try and introduce us to the importance of museums and why these facilities are such amazing places to unlock knowledge. This animation is also going to introduce us to the fascinating world of deep sea corals, and you'll get a go at trying to link up names to some of the common coral species that we find in the deep. You also have a hands-on um, practical activity that will help you understand or gauge how taxonomy really works. So the detective work that goes into it, the step-by-step process. And I'm really hoping that you'll find this interesting, exciting, and worthwhile. So yeah, without any further delay, let's have a look at the animation. Museums are well known as a place that safeguards knowledge. Here is where you get the opportunity to walk in the footsteps of some of the most impressive explorers. And with enough patience, you can unlock the cabinets of curiosity and share these discoveries with the world. A good example of how museum collections improve our understanding of the environment around us is the discovery of deep sea corals. Some of my work is built on the foundation of multiple explorers who date back to the 18th century, a time in history referred to as the Age of Reason. Because of the time and effort put into studying corals, we now know without a doubt that deep sea corals are a bunch of various closely related animals that do not need sunlight to survive. Even though deep sea corals have similarities, hence we say they're close related, some of their physical features differ and tend to be quite distinctive to a particular group. And to demonstrate this, we will have a look at four major groups that may vary in their skeleton and body structure. But before that, let's see if you can have a go at telling these four groups apart.
Wow, that animation was so awesome. Thank you for sharing that with us, Zoleka. So students, we just heard from Zoleka that deep sea corals are a branch of variously closely related animals that do not need sunlight to survive. But since they have so many similarities, how do scientists even tell them apart? Zoleka is going to tell us about four major groups of deep sea coral, but first she wants to put you to the test. So let's have some fun. Do you think you could identify deep sea corals? We're going to show you pictures of four types of deep sea corals, and we will see now if you can actually match them to the correct name in the image. So here's a hint. The common name describes the physical features of the coral. Okay, so students, have a look at A. What type of deep sea coral do you think this is? Pick a common name from the list on the right. Is it a black coral, a stony coral, sea fan, or lace coral? Right. Students, tell your teachers, and teachers, go ahead and type your students' answers into the chat. Remember the hint. The common name describes the physical feature of the coral. Okie doke. Let's see what some of you guys are saying for A. I'm seeing a lot of people say black coral for A. And that comes from Kimberly, CID, Elise Tang, Andres R, WMS Wildcats, Isabel. I mean, honestly, everyone is saying black coral. I do see a C fan there with Andre Cervantes, but most people are saying A is black coral. All right, great answers. Let's move on to the next one. We'll have Zoleka tell us all the answers after we've tried to guess them, all four of them. So let's go on now to B. What type of deep sea coral do you think this is? Pick a common name from the list on the right. Teachers, go ahead and type your students' answers into the chat. Question is, what coral is B? Black coral, stony coral, sea fan, or lace coral? All right. I'm seeing a lot of people say stony coral. I suppose it looks quite stony. Juan says sea fan. WS Wildcats goes ahead and says that A is black coral and B is stone coral. So I'm seeing a lot of stone corals here. I'm seeing a lot of sea fans. It looks like a nice 50-50 split, but we'll go on to the next one. All right. So what is the picture C? Is the whitish looking coral here. Kimberly CID says that one is indeed the sea fan. Okay, what do you guys think? Is Kimberly right? Oh, Adam's family homeschool says lace coral. I'm seeing sea fan come in. I'm seeing black coral come in. Isabel says sea fan. Andre says sea fan. All right. And okay, a couple more. C, stony coral. All right. Now we're going on to the last one, which is D. What do you guys think D is? Sheila says black coral, and so does Jimmy. I'm seeing lace coral, sea fan, lace, lace, lace. A lot of people think this is lace coral. I'm seeing sea fan here. Man, it's like completely split. And honestly, do not ask me what this is because I have no idea. So we are going to actually ask the professional expert on corals here. So let's hand it back over to Zoleka to give us the answers and explain the similarities and differences between these four major groups of deep sea corals. Zoleka, want to tell us what the answers are? Because I have no
As soon
idea.
as I unmute myself.
Yeah.
Um, Yeah, wow. I must say, guys, that was a very good run. Well done for having a go and trusting your eyes. There's a good combination of some correct answers there. And I am just gonna quickly walk you through the correct answers, or at least the names that we have assigned to these corals as taxonomists. For all of you guys who said A was a stony coral, yay. That is a stony coral. B is a sea fan, C is a lace coral, and D is a black coral. Now, I must say this activity is really something quite difficult. I sometimes struggle to identify corals from just a picture because of the orientation. Sometimes you can't actually really see what you want to see to be able to tell the coral apart. So to help you refine or better understand why how we got to these names, I am going to start off by comparing the sea fans and the black corals. And that's mainly because these two animals share quite a few similarities. And I like to refer to them as the heroes of the ocean because they bend, but they don't break easily. So we refer to them as being flexible. They're also made up of a number of individual corals. So not just one coral, it's like multiple corals working together. So we refer to them as being colonial. They have this fan-shaped appearance, both of the species, but some black corals actually have a whip or a coiled appearance, right? So that's how the black coral differs in terms of shape to the sea fan. The one unique thing, though, about the sea fan is that it has its skeletons crystallized in patches in the body, right? So this means that basically it's the skeleton, the patchy skeleton gives the coral its shape, but it also allows it to be quite flexible. I think it's one of the most flexible corals from all four corals. Yeah. And then in terms of the black coral has a very visible and solid skeleton, and it tends to have this black color because of the material that actually makes up the body. We're going to move on now to the lace coral and stony coral. And just by having these two corals alongside one another, you can tell that they're way different um, from the sea fan and the black corals. So they're quite similar, though, in that they're also colonial. So they're made up of multiple coral individuals. But they're different from the sea fan and black coral in that their skeleton is very rigid. It's strong, it's a solid skeleton. This means that the animals don't really sway and move with the seawater as the currents are coming through. Their skeleton is also quite white and visible. But they differ, the lace coral and the stony coral, in how they branch, so the orientation of their branching. So with the lace coral, I like to think of it as a snowflake. With the lace coral, it sort of branches in one direction, and then the underside is very smooth. Whilst the stony corals sort of branch in all sorts of directions. There's a lot of chaos in its branching, and it gives off this tree-like appearance. But the interesting thing about stony corals is that you also find species that do not mind chilling on the seabed by themselves. So they're just individuals. They're not part of a group. They're not part of a community, and they just live their best lives as loners of the deep. So then we refer to those as solitary. But the one thing, I guess, that you might have picked up is that the similarities that I've mentioned and the differences that are quite unique to individual corals are really hard to see from a picture. And this is mainly because as scientists and taxonomists, we have really built an inventory of how corals look like based on a very small fragment that we get from a live coral. So they tend to look very, very different. And once we get this fragment, we clean off the tissue and then we're just left with the skeleton. And an example of this is what you see on my right-hand side. So that's a fragment of the live stony coral that the image that we used in our activity that we just did. So, but the nicest thing nowadays is that we have the amazing technology to now go down there to the deep, take pictures of a coral, pick a fragment, go and analyze it on land, and then link up the identification to what is live, right? And over time, we build this library, this inventory of how things look like. And the more we go out and we see them in their natural environment, we sort of like can easily identify corals without having to have a fragment, you know? So it's exactly as how you guys can just recognize a cup before, and you don't even have to think about it. So you've built a muscle memory. It's like walking. At some point when you were growing up, you were taught how to walk, but now you just walk freely without even thinking about it. So you build up that muscle memory. And the one thing with stony corals, so I'm going to focus on stony corals because that's where my interest and my expertise are. Um, so once you want to get down to the detective work of identifying an animal by looking at the physical characteristics of it, you really need to expose the skeleton, right? And once you have removed the tissue and you have a skeleton, you have to go to the literature, find out who has worked in your area, which animal, which species they've worked on. And if you can't find a local expert, then you branch out and start looking internationally. You read books, and really this literature search is going to help you build the jargon. So as taxonomists, you know, we give these features very unique names. And the whole point of giving these features a unique name is so that we have a unified way of speaking. So taxonomy is really like learning a new language for that particular taxonomic group. So even though I'm a taxonomist with stony corals, once I go to sea spiders, I am going to have to learn that language so that I am able to recognize whatever the literature of the books are telling me. And what you see on my left-hand side is a clean skeleton, a schematic of how a stony solitary coral, so an individual coral, would generally look like. And as you can see, there's a lot of fancy terminology there. But the one that I really want us to focus on is the corallum, which is a fancy, really fancy word, top-notch word that basically means body. So we are looking at the body of the skeleton. And within the body, you will get smaller components where you would focus more on the shape, the appearance, if it's smooth or if it's rough. And to be able to do this, you really need a microscope, right? So that's like the third tool. And as you are going back and forth, you really need to take notes. So you need to keep track of what you understand, how you understand it, where you found information. And to put this in practice, I have developed this very simplified, very, very simplified, a decision tree that is going to focus on the corallum. Remember, corallum, body. Okay, so the skeleton, which is going to focus on some of the very high level characteristics of a corallum. And on my left-hand side is the coral at question that I'm going to use as an example. And on the right-hand side, my right-hand side is the decision tree. So I'm going to walk you through this step by step because taxonomy is a systematic thing. It's a systematic process. So you do it step by step. And it's okay if you get lost along the way, you just start all over again. But believe me, it's really exciting and fulfilling when you have actually cracked the code. Okay, so this coral, when you look at it, first question you need to ask yourself, is it made up of one coral or does it look like there are several corals working together as one? And I have some schematics as examples there. Comparing the coral on my left-hand side with the schematic on the right-hand side of the decision tree, I think it is one individual. It looks like one individual. There's only one cup opening up, though it is attached to something or it looks like it's connected to something, right? But it's one individual. So I'm going to go with one individual. Let's see where that takes us. Probably gave it away too soon. I said attached. Foo, Zoleka. But corals tend to be attached to something, okay? Some of them, especially the corals that you find associated with a hard substratum, okay? Whether it's rock, whether it's pebbles. But you also find some corals that live that thrive, without being attached. They have attachment issues really. So they are not attached to seabed and you find them on soft sediment, mud, etc. But looking at our example, and seeing that there's a base there that is sort of like hugging the outer circle, I think this coral specifically is attached, even though it seems like it sort of grew on another coral. Corals also do tend to do that. They fight for space and it's survival of the fittest in coral world. But anyway, I definitely think this specific coral is attached. Let's see where that takes us. The next level or something we should be asking ourselves is whether the skeleton has tiny holes or not. Okay, is it porous? Does it have the spongy look, or does it have like a solid skeleton? And once again, quite difficult to see from the picture. That's why generally we would use a microscope, and that will really help you zoom in there and magnify and see it in a higher resolution, which we have done. And the part that we're looking at is where that square, is it a square? Yeah, it's a square. Sorry. A square is, and based on that, I definitely think that this specific coral has no holes on its skeleton. Okay, and now we are going to see where that takes us. Yay! We land on Caryophilia. Once again, this was a very overly simplified decision tree, but this is generally how taxonomic trees work. You have a set of characteristics and you have to choose till you get to the end. From here, once you've gotten somewhere, then you go back to the literature and you look at where was Caryophilia, where do you find this genus, how many species, which species is most likely going to be this one. And, that is phase 2. But anyway, that is me walking you through a very simplified decision tree that focuses on a corallum. And I'm going to hand over to my fellow explorer, Gibbs, who is going to see and talk you through your next activity.
Right on. Well, thank you for guiding us through that incredible investigative process. I mean, it really shows how the work of science is done. I mean, I absolutely love that. So thank you. Okay, students, it's now your turn. Let's try to classify deep sea coral following the same steps that Zoleka just walked us through. So let's take an image, take a look at the image of the coral on the left side of the screen. And now let's just use the key like Zoleka did to classify it. Okay, let's go through the process together. So for the coral that you see there on the left, is it one individual or many? Students, tell your teachers, and teachers type their answers into the chat. All right. What do you guys say? Oh man, someone's already got the answer. All right. So one individual. I am seeing one pretty much across the board. That's coming from Kimberly, Zoe, Andre, Sarah, Juan, Adrian. You guys, okay. It's one individual, not fooling you there. Well done. Okay, this one maybe get a little bit harder on the next step. Let's see. So the next step is it free or is it attached to something? Teachers, tell us what your students think. Okay, seeing a lot of free. Okay, I thought it was going to be a bit harder, but you guys are actually nailing this. Everyone says it's free. Narek, Sheila, Philip, Daniel, uh, Narek again. Oh man, okay. It's free. It's free across the board. Free answers. You guys are absolutely right. All right. So this means that the coral is A, and um, we have an option here. If you know the coral is free. All right, everyone gets it. It is Sphenotrochus. Sphenotrochus? Zoleka, how did we do?
Yeah, you guys did pretty well. Very, very impressive. I'm actually worried that I'm going to be out of a job after this classroom event. Like, that is spot on brilliant. That is brilliant. Hopefully next time we can add other features and let's see how people do then. Yeah, no, this was absolutely spot on. Wow.
Yeah, they
Do we have
nailed it.
time for another one? Another run?
Yeah, I think we should try another one. All
Yeah.
right. So since we all are professionals at identifying deep sea corals, let's put it into practice. Thank you for leading us through that activity, Zoleka, and joining us today. Um, let's do another one. All right. So is this one individual or many individuals? Okay, seeing some answers come in now. Kaya says one, Isabel says one, Sarah says one twice, but it seems like it's still one. Elise says one, Narek says many. Okay, interesting. All right, so it is indeed, the answer is, it's one. All right, okay, now the next step. Is this coral, is it free or attached? Kaya says attached. Jaden says, oh, I don't know, I'm seeing more attached here. Juan says attached. Mrs. Lee, 8th grade STEM class says attached. I'm seeing attached across the board. And it seems like it is indeed attached. Man, not fooling you guys. Now, we have a couple options here. Of the two options of attached corals, one has tiny holes and the other one does not have tiny holes. And based on this, you should be able to get your answer. So I'm seeing tiny holes, balanophilia. I hope I said that properly. A lot of tiny holes and balanophilia is coming through. You know what? I think I'm gonna have to ask Zoleka if this is indeed the right answer. What do you say, Zoleka?
Spot on.
No
You guys
way,
are
they nailed it.
so impressive. Nailed it. Like, wow. Yeah, yeah,
That's all. That's
yeah,
100%. That's 100%.
yeah. Wow, so impressive. Yeah, maybe next time we should add more features in there and just more species and see how that goes. That will be very exciting.
I think a bunch of you
Um,
guys are about to get internships also as
yep.
coral scientists.
Yeah, so that's the world of corals. And one thing that you must remember with taxonomy, it's not really just about identifying and putting a name to a coral face. You also get some cues around the ecology of the animal. So how it lives, how it reproduces, how it interacts, how it might be feeding, because, for example, if you have a solitary coral that's attached to the ground, okay, it can't move, right? It has to stay put in one place. So it's going to be found in an area that has seawater constantly moving because that comes with their food. So the coral can just like hang their polyps out and capture food as it's passing by. If it's attached, if it's solitary, that means that, what do I want to say about solitary? What do I want to say? Okay, I don't have a good example for solitary. But if it's a colonial stony coral, you know that these corals tend to build reefs in the deep, and they change the sort of like topography, so the bottom of the seabed. And that is very important because now certain animals get a space to attach, certain animals get to experience home far from home, right? So if you're an animal that really likes rocky areas and you find yourself in a muddy or sandy space, the coral gives you a reminder of home, and you can thrive and you can survive, you know. So there's a lot of cues around the physical characteristics of an animal. And if you're unattached, you know, you somehow can move freely. So you're not really tied down to one spot. So you can move around, you can make use of the currents, so the movement of the water and the movement of seawater in the deep, make use of the currents and hop from one spot to another spot.
Yeah, so it
And if you
sounds like
have
these
a,
corals are quite dynamic, huh? They
yeah,
can
yeah.
use different spaces, they can kind of take over different areas by essentially surfing the waves into different parts of the ocean. That truly fantastic stuff.
That's a
Um,
brilliant way of putting it. Yeah,
yeah.
surfing the waves. Love that.
So I think we better kick off the Q&A portion of the show. So if you're watching online, you can send us your questions in the chat bar, and we'll record all of them as they're sent in. So please only send in the question once, please. And teachers, you can let us know who's asking the question so you can give your student or the class a shout out. So if you're an on-screen guest, please get ready with a nice loud voice, and we will tell you when it's your turn. Okay, so the first one is going to be a question from YouTube, and it comes from Elijah. And he wants to know, why do corals not need any sun?
So deep sea corals specifically don't need any sunlight to survive, because in the deeper parts of the ocean, there is not much sunlight. So these corals have adapted a way of living to be able to survive in those environments. You get shallow water cousins, you know, the counterparts of the deep sea corals that live in shallower waters. You know, they have access to sunlight. And you tend to see these corals a lot in tropics, temperate areas. And they rely on the symbiotic relationship with an algae. And so basically, the algae has a safe space to hide, to thrive as well. But at the same time, in return, so its rent is to provide coral with the food that it needs to be able to grow and survive. But that's because the only way the symbiotic relationship can really exist is because they are in an area that has access to sunlight, right? Or else there won't be that symbiotic relationship. So the deep sea corals do not generally get exposed to sunlight. Although you do find them now in shallower waters. You find deep sea corals in shallower waters. So it's not really about the depth, but it's more about how they acquire their energy. How do they get their food to be able to maintain themselves, to grow, to reproduce, right? But we also get a group of corals that can be found in deeper waters that can have these both feeding strategies. You know, they have the symbiotic relationship with the algae, but they also can just feed on zooplankton. So most deep sea corals feed on zooplankton because they don't have the symbiotic relationship. So you have the specific species that is basically piggybacking on both sides. It can't choose a side. It's on a fence. You know, so it's quite interesting how these corals have evolved different ways to be able to survive in their respective environments.
Question to that is, what did you name the species?
Oh, what did I named it after, I named it Etnopsamia. So I named it after my late minister. So I work for a government entity, and she was really a pioneer in establishing our offshore MPAs. And if it wasn't for her, actually, we wouldn't have had that expedition to go to that specific area and have the pleasure of finding this coral. So I honored her and named the genus after her.
What a beautiful homage. I love that. Very cool. Right on. All right. Some folks from YouTube are wondering, what inspired you to do this work? So the question is, what inspired you to be a coral biologist in taxonomy?
Ah, yeah. Thank you so much, Gibbs, for saving me and being specific because I was just like, which work? That's like the ocean is just so amazing. And I'm in so many parts of the ocean and I'm looking at different components of the ocean. What inspired me, I think I'll start off with what inspired me to just work in the ocean space. It's really just the complexity of the ocean and how dynamic it is. You can
Mm.
literally go to the same spot every single day and there will be something new to see. There'll be something new to discover. The ocean is so moody and she's so graceful at the same time. And to think that there's like incy wincy animals out there that have adapted and have just evolved over years to be able to survive in that environment, which seems very harsh to us, but it actually not is not for them. With corals specifically, focusing on corals and pursuing that as a PhD, what really inspired me there or got me going was the fact that there hadn't been a coral deep sea taxonomist in my country for like 40 years. And since at that time, I knew how important corals were ecologically, I was like, no, I really want to understand these people. These guys are not getting attention. They're not getting the attention they need. So yeah, that inspired me to look into corals.
Yeah, and way to fill the gap. I mean, you've created huge shoes for the next person coming along. All right.
Yeah.
All right. Rex on YouTube is curious. What's the deepest living coral that you've studied?
Hmm. Deepest living coral that I have studied. Well, technically, all the corals that I've studied are not living because I get the fragment of a live coral and then I clean it. And at that point, by the time it gets to me, it's already dead because of the pressure change. So we know that the deeper you go, the higher the pressure is. So then when they come out, they just lost. They're not in the environment. They won't be able to survive, right? So by the time they get to me, they are quite dead. But the deepest coral I have seen in a sub, I was in a submersible dive,
Whoa.
was at 800 meters, 800, 900 meters. And
Whoa.
that was a brilliant, that was really something else. You know, when you're in a sub, it's like you're basically hiking underwater. It was beautiful. I came across these patches of the coral we call Enelopsamia, and I'd never seen it live before. And I thought it was a lace coral because it was so similar to a lace coral, and I couldn't just get close and I couldn't touch it. But luckily, we were able to sample a fragment. And then I was like, yes, once I saw, I was like, yeah, this is Enelopsamia. This is Enelopsamia. It was so beautiful and so moving. So yeah, sometimes even though you've dedicated some time to studying an animal, you don't really get to see it live in its natural environment. That's a very rare thing, especially for animals in the deep. But I have had the opportunity to actually, you know, come across a coral reef at 800, 900 meters, which was really cool.
Man,
It was really cool.
submarine adventures. This is like a Titan Gate 2.0. All right, Kim. All right. I think we have one more question from us, and that is, what final message do you have for the students watching?
Oh, final message I have for the students watching is never let go of your sense of wonder. You know, daydream, ask questions, observe things. There's no such thing as a stupid question. There's only an unasked question. Ask as many questions as you need to be able to get to a better understanding of any subject. Stay true to yourself. You know, your passion is going to be your anchor as you navigate this world. Being explorer comes with a lot of challenges, but the nicest thing is that along the way, you learn how to solve these challenges, you know, so you have to be problem solver, you need to be curious, passionate, and those are the things that are really just going to drive you through everything. And there's no age. There's no age limits. There's no age start. It doesn't matter where you come from. And there's so many opportunities to be an explorer beyond taxonomy, beyond the ocean, beyond being a scientist or an engineer. You can just be an explorer by really asking questions and observing and being interested about the world around you. So stay true to that, however that looks like for you.
Yeah, wow. Thank you for that beautiful response and for joining us today, Zoleka. And honestly, just inspiring us with your final message. So thanks.
Bye, everyone. It was such a pleasure. I hope I get to connect with you guys soon again. Thank you so much. Thank you, Gibbs. Thank you to the teachers for organizing and making sure there was like an amazing set of learners joining in. It has been such an honor. Thanks to Nat Geo for giving us a platform to be able to connect with people that we generally wouldn't be able to connect with. I'm on the southern tip of Africa with no electricity and it's nighttime, but this has been the best nighttime party I've ever been to, way beyond my bedtime. So thank you so much. Thanks, Gibbs. Bye,
Yeah.
guys. Bye, guys. How do you do the heart thing? I don't know. I'm like so old. Thank you.
Nice. We do the border. We do the border.
Oh, it is a, I don't even know how to do it. Oh, the
Yeah,
border.
yeah.
Okay, there you
These
go.
kids will show you. All
Yeah, they
right.
are
Thank
showing
you.
me. They have been showing me, but I'm just not doing it.
Yeah, thank you, students, for your thoughtful questions. And of course, thank you, teachers, for bringing your classes to our show. We are already well into a very exciting season of Explore Classroom, and there's so much more ahead. Check out our event schedule and register for events at natgeoed.org/explorer classroom. When you register, you can request a chance to be featured up here on screen with us. We'll be joined next week by explorer and biologist Brandon Quintana. His research is focused on the health of organisms like oysters and living shorelines. Join to learn how living shorelines can better protect coastal communities while increasing habitat and biodiversity. That's it from us. Have a great day, everyone. Stay curious and keep exploring. We'll see you next time. Ciao. Bye-bye.